So this example is a continuation of the previous example. Here we're going to solve the due date company problem using the Simplex method. Now we already solved this problem in the previous section by graphing. We determined each one of the vertices of the feasible set that is formed by the system and then checked which vertex or coordinates yielded the largest profit. And we determined that x is equal to 28 and x was widgets, y was equal to 6 and y was the gadgets, and the profit, the maximum profit, was $69.20. So we solved that previously by graphing. This time we're going to solve it, of course, using the Simplex method. Now just a couple of things to point out here. We have these unit columns right here for each one of the slack variables and for the objective function here. These values are known as basic elements here, basic values. We want to change the non-basic ones. Those are the ones over here, the x and the y. These are the ones that we're going to change into unit columns. Also, we have a decimal here. It's best to work with fractions rather than decimals. Even though we're dealing with money, we could always change it back at the end, but it's much easier and cleaner to use fractions. So I'm going to change this negative 2.2 to negative 11/5. Negative 11/5. So when we use the Simplex method on a linear programming problem, after we've changed it into a Simplex tableau, we go through 3 steps. The first step is to determine the pivot element, which we already did in the previous example, and it was 5. So this 5 we're going to change into 1, and then we're going to change this column into a unit column, and we're going to do that by using elementary row operations as we've done in previous sections. So to change this into 1, we'll take 1/5 of row 2. Put in a bracket. 1 times 1/5, that's 1/5. 5 times 1/5, that's 1. 0 times 1/5, that's 0. 1 times 1/5, that's 1/5. 0 and 0. We can put in our vertical line. 100 times 1/5, that's 20. Okay, close off our bracket, and then we fill in the rest. 5, 4, then 164, 2, 3, 0, 0, 1, 0, that's 74. Then negative 2, negative 11/5, 0, 0, 0, 1, and 0. And finally, we'll put in our horizontal line here. So now that we have this as 1, we're going to start targeting the rest of these values here. We could start right here with 4 in the first row. So we could take row 1 minus 4 times row 2. Put in our bracket. 1/5 times 4, that's 4/5. 5 minus 4/5, that's 21/5. It's much easier using fractions. 1 times 4 is 4, and 4 minus 4, that's 0. That's the whole idea, right? 0 times 4, this winds up being 1. 1/5 times 4, that's 4/5. 0 minus 4/5, that's negative 4/5. This winds up being 0, then 0. Put in our vertical line. 20 times 4, That's 80. 164 minus 80 is 84. Close off our bracket, and then we fill in the rest. Put in our horizontal line. So now that we've changed this one, we can now target this element. So we'll take row 3, and we'll minus 3 times row 2. So 1/5 times 3, that's 3/5. 2 minus 3/5, that's 7/5. So hopefully you can see how using fractions is really advantageous here. So then 1 times 3 is 3. 3 minus 3, 0. That's the whole idea. This is 0. 1/5 times 3, that's 3/5. 0 minus 3/5, that's negative 3/5. Then this is 1, and then 0. Bring down our vertical line. 20 times 3 is 60. 74 minus 60 is 14. Close off the bracket, and we can fill in the rest. And then put in our horizontal line. So you can see how we're building a unit column here. So now we'll target this value right here. So we'll take row 4 and we'll add 11/5 of row 2. Put in our bracket. 1/5 times 11/5 is 11/25. Negative 2 plus 11/25 is negative 39/25. 1 times 11/5 is 11/5. Negative 11/5 plus 11/5 is 0. Of course, that's the whole idea. Then this is 0. 1/5 times 11/5, that's 11/25. 0 plus 11/25 is 11/25. This is 0. This is 1. Bring down our vertical bar. 20 times 11/5 is 44. And 0 plus 44 is 44. Close off our bracket, and we fill in the rest. So as you can see, we changed this column into a unit column. One of the elements is a 1 and the rest are zeros. Now, step 3 says that we have to check for optimization. And we can tell when we've achieved optimization is when all the values in the last row here are non-negative. And obviously we could see right here we have a negative value here. So since we have a negative value, we have to go through this whole process again. But this first process that we just did, we call that our first iteration. And sometimes it'll take 2, 3, maybe 4 iterations before we have all positive values in our last row here. But since we don't, we have to go through this all over again. So we'll start this again by determining our pivot value. So now that we've moved our matrix up here, we're going to start the process again. And the first step is we're going to look for a pivot element. And of course, the first step says that that pivot element will happen with the most negative value in the last row here. And of course, this is the only negative value here. So this is going to be our pivot column. And of course, then from the pivot column, we determine our pivot row. And again, we do that by taking the constant here and dividing each value in the pivot column into its constant. So then 84 divided by 21/5 is 20. 20 divided by 1/5 is 100. 14 divided by 7/5 is 10. And of course, the value with the lowest ratio, that becomes our pivot row. So that's this one right here, where the two overlap right here. That becomes our pivot element. So we're going to change this value into a 1 and then change the rest of this column into a unit column. So we'll do that. So we'll take 5/7 of row 3. Put in our bracket. 7/5 times 5/7, that's 1. 0 times 5/7, that's 0. 0, 5/7, 0. Negative 3/5 times 5/7, that's negative 3/7. 1 times 5/7, that's 5/7. And of course, 0 times 5/7 is 0. Bring down our vertical bar. 14 times 5/7 is 10. Close off our bracket, and we fill in the rest. Put in our horizontal line. And as you can see, we now have 1. Now we could target any one of these elements. How about if we start with this one? So we could say row 1 minus 21/5 of row 3. Put in our bracket. 1 times 21/5 is 21/5. 21/5 minus 21/5, that's 0. That's the whole idea, right? 0, 0, that'll be 0. 0, this will be 1. Negative 3/7 times 21/5, that's negative 9/5. Negative 4/5 minus negative 9/5, or in other words, negative 4/5 plus 9/5 is 1. 5/7 times 21/5 is 3. 0 minus 3 is negative 3. This is 0. Bring down our vertical bar. 10 times 21/5 is 42. 84 minus 42 is 42. Close off our matrix, and we fill in the rest. Now we put in our horizontal bar. So we can now target this element here. So we'll take row 2 minus 1/5 of row 3. So we'll continue over here. 1 times 1/5 is 1/5. 1/5 minus 1/5. That's 0. Again, that's the whole idea. 0, 1/5. This winds up being 1. 0, 0, and 0. Negative 3/7 times 1/5. That's negative 3/35. 1/5 minus negative 3/35, or in other words, 1/5 plus 3/35 is 2/7. 5/7 times 1/5 is 1/7, and 0 minus 1/7 is negative 1/7. Of course, 0 and 0, this is 0. Bring down our vertical bar. 10 times 1/5 is 2, and 20 minus 2 is 18. Close off the matrix, and we fill in the rest. Put in our horizontal bar. And we have this element. Now we could target this element here. So we'll say row 4 plus 39/25 of row 3. One times 39/25 is 39/25. Negative 39/25 plus 39/25, of course, is 0. 0, 0, and 0. 0, 0, and 0. Negative 3/7 times 39/25 is negative 117 175. 11/25 minus 117 175 is negative 8/35. 5/7 times 39/25 is 39/35. And of course, 0 times 39/25 is 0, so this remains 1. Bring down our vertical bar. 10 times 39/25 is 78/5, and 44 plus 78/5 is 298/5. Close off our matrix, and we fill in the rest. Put in our horizontal bar. So we've now changed this into the unit column. And step 3 says now we have to check. And of course, we check by seeing if there's any non-negative values in our last row here. But there's not. We still have this one right here. So again, we start the process over again. So this winds up being our second iteration. But we repeat again. So of course, as we do the process again, the first thing we want to do is determine a pivot value, a pivot element. And of course, that's going to occur in the column with the most negative value in the last row here. And there's only one, that's right here. So automatically, this is going to be our pivot column. Then to determine which value, we go ahead and we divide each one of the values within our pivot column here into our constants. And we only want positive results. So the negative 3/7 we won't even do because we want our results to be positive here. So we'll take 42 divided by 1. That's 42. And then 18 divided by 2/7. That's 63. And of course, we want the pivot row will be the one with the smallest ratio. And of course, that'll be this one right here, where the two intersect, the pivot column and the pivot row. That becomes our pivot element right here. So it'll be 1. So now we continue with our row operations. We could go ahead and target this value right here. So we can say row 2 minus 2/7 of row 1. Put in our bracket. So we start with 0. That'll be 0, and of course 0. So our first entry here is 0. 0, that's 0, so we end up with 1. 1 times 2/7 is 2/7. 0 minus 2/7, that's going to be negative 2/7. 1 times 2/7 is 2/7. 2/7 minus 2/7 is 0. And again, that's the whole idea. Negative 3 times 2/7, that's negative 6/7. Negative 1/7 minus negative 6/7, or in other words, negative 1/7 plus 6/7, that's 5/7. 0 times here is 0. Put in our 0. And then we can put in our vertical bar. 42 times 2/7 is 12. 18 minus 12 is 6. Close off our bracket here, and then we fill in the rest. Put in our horizontal line. And as you can see, we're starting to turn this into a unit column. We could go to this, target this value here. So then we'll do row 3 plus 3/7 of row 1. We'll continue over here. 0, 3/7 is 0, so 1, so we bring over the 1. 0, 0, 0. 1 times 3/7 is 3/7. 0 plus 3/7, that's 3/7. 1 times 3/7 is 3/7. Negative 3/7 plus 3/7, of course, is 0. That's the whole idea again. Negative 3 times 3/7, that's negative 9/7. 5/7 minus 9/7, negative 4/7. 0, 0, and 0. And we bring down our vertical bar. 42 times 3/7 is 18. And 10 plus 18 is 28. Close off our bracket and copy over the rest. Put in our horizontal bar. And we have the final element right here. So we'll take row 4 plus 8/35 of row 1. Put in our bracket. 0, 0, and 0. Copy it over. 0, 0, and 0. Copy it again. 1 times 8/35 is 8/35. 0 plus 8/35, 8/35. 1 times 8/35 is 8/35. Negative 8/35 plus 8/35, and of course that's 0. That's the whole idea. Negative 3 times 8/35, that's negative 24/35. And 39/35 minus 24/35 is 3/7. 0, 0, bring down the 1. Put in our vertical bar. 42 times 8/35 is 48/5. 298/5 plus 48/5 is 346/5. Close off our matrix, and we bring over the rest. Put in our horizontal bar. So now we change this into a unit column, and then step 3 says, now we check, and we check by seeing if there's any negative values left in the last row here, and there isn't. So we're done with all of our iterations, and this was the 3rd iteration. I'll just put it right here. Our 3rd iteration. Sometimes there's 2, sometimes there's 3, sometimes there's 4. And as you can see, the work can be very tedious, but it is doable. It's basic elementary arithmetic. But what we can see right here is 346/5. Well, that's equal to 69.2. And since we're talking about money, we'll make it $69.20, which of course matches what we have up here for maximizing our objective function from the previous chapter. Here we have x. X is 28, and that's what we have here. And here is our y, and y is 6. And we can see that's what we have right here. So this is a very convenient way, rather than have to graph find intersections and to check all the values. All we do is keep doing these iterations until we have nothing but positive values in the last row here. Once that occurs, then we know we are done and we have reached an optimal value, and that winds up being the solution for our linear programming problem. And that's it.